Hi everyone, I'm Cheryl. In this problem, we're going to be sketching the space curve that is the intersection of the surfaces z equals x squared plus y squared and x plus y equals 0. And after we're done, we're going to get a vector valued function that represents that curve. Okay, let's begin by getting the surface z equals x squared plus y squared. Well, I'm going to use traces to help me get this. And the first thing I'm going to do is get the trace in the YZ plane. So we're going to look at the YZ trace. And for this particular YZ trace, I'm going to let x equal 0. And when I do that, I have z equals y squared, which is just a parabola in the YZ plane. So let's go ahead and mark that down. I'm going to have a parabola, just a standard parabola. So when when y is 1, z is 1, and when y is 2, z is 4. It's going to look something like that. Okay, now let's go ahead and look at the xz trace. And when I look at the xz trace, I'm going to let y equal 0. Well, when I do that, my formula becomes z equals x squared. So in the xz plane, I'm going to have another parabola. Now, I'm not going to draw this one in, but if you can envision, it's a parabola that comes down and through the origin and back across. And it's in the xz plane, the plane that's coming out towards you. Okay, so I've got another parabola shape. So the only other trace we have not done yet is going to be the xy trace. And I've been letting the other variable equal 0. So let's see what happens in this case when z equals 0. When z equals 0, I'm going to have 0 equals x squared plus y squared. Well, that's just a point. It's this point right here. That doesn't give me a lot of information. So let's try another trace, letting z be equal to, say, 1. If z equals 1, my formula becomes 1 equals x squared plus y squared, which I know is a circle. So when z equals 1, I'm going to have a circle. And again, remember, I'm in the xy plane. So my circle is going to be oriented in a horizontal fashion, like that. Now, if you can imagine, if z were to say equal to 4, I would have a circle of radius 2. So I'm going to have a whole bunch of circles going up the z-axis, right? And so now what I've done is I've created a surface that's called a paraboloid. All right, that's my very first surface. Now I have to look at my second surface. I have x plus y equals 0. Notice that there's no z variable in this. If I solve for y, I'll have negative x. Basically, what this is telling me is that y equals negative x no matter what the value of z is. So let's start out, well, what happens if z equals 0? Y equals negative x. So I'm in the xy plane, and so let's just say that x is 1. If x is 1, y is going to be negative 1. So that's going to give me this point. And again, z is 0. Let's say z equals 1. I still have y equals minus x. So I'm going to come up higher, but I'm still going to be right at this value. Let's try another point. Let's do x equals 2. If x equals 2, y equals negative 2. So I'm going to come across here and down, and I've got this point. So what I've got, if z equals 0, I've got a line that goes through those points. But again, as I mentioned before, what if z is 1? Well, this line basically moves up to 1. And if z is 2, it moves up to 2, and so on. So what I'm doing is I'm creating a plane in my three-dimensional space. So if I draw a plane in here, this is what my surface is going to look like. Now again, I have boundaries on this, but think this plane goes up forever and it goes below forever, just like the paraboloid continued up forever. Okay, now the point of this problem is to find the intersection of these two surfaces. So what I'm going to do is look at the intersection, and it's going to end up looking if you can imagine, like a parabola. So that is the curve that's the intersection of these two surfaces. Well, the last part of this problem is to get a vector-valued function that represents this curve. All right. Again, we know that there are many ways of doing this, but we're going to start out by letting x equal t. So if x equals t, I know that any point that's along this curve, so any point along here, is also on my plane, okay? Which means that since y equals negative x and x equals t, we know that y will equal negative t. In a similar way, any point that is on this curve also has to be on my paraboloid. So I know that z equals x squared plus y squared is the equation for my paraboloid. And I know that x is t, and I know that y is minus t. So I have t squared plus t squared, or 2t squared. So now I can write my vector-valued function as t times I minus t times j plus 2t squared times k. I hope that was helpful. Thanks.